Okay, now we're going to look at some applications of the factor theorem, and we're going to start with when we're provided with the factors, how can we then go about and generate a polynomial? Okay, so let's have a look at this question here. We've been told we've got a monic cubic polynomial and the zeros are at -1, 3 and 4. So from the work that we've done previously in our slide presentations, hopefully you remember that a polynomial, when we're told there are roots here, can be presented in this form. A outside of x minus each of the roots. And remember, at most, because this is a cubic polynomial of degree 3, we've got 3 roots. Now, we've also been told this is a monic polynomial, so we know that the value of A must be 1. Since it's monic. So therefore, we have a polynomial in the form of A, which is 1 outside of x plus 1, x minus 3, x minus 4. And we don't need to write this 1 out the front, so we can leave it simply as x plus 1 times x minus 3 times x minus 4. Okay, now we've got another cubic polynomial, this time a leading coefficient of 6, and the zeros are at 1/3, -1/2 and 1. So again, we're going to set it up in the form of px equals a outside of x minus each of our roots. So polynomials in the form where a is our leading coefficient, and in this case it's 6, and we've got roots at 1/3, -1/2 and 1. Okay, so we don't want to leave it in this form. We'd like to have roots that are like inside the brackets. Here we want to have integers rather than fractions. So what I'm going to do is split up this 6 into factors, and we've got factors of 6 that are 3 and 2, and I'm going to rewrite it like this. So you can see that we can actually multiply in and eliminate these fractions here. So multiplying 3 outside of x minus 1/3, we end up with 3x minus 1. And let's multiply this 2 in here, so we end up with 2x plus 1, and then times x minus 1. So this is the best way we can leave our final answer in factored form, rather than here where it's a bit clunky, where we've got fractions inside. We want to, where possible, have integers in our final answer. So now we can have a go at some further application.